Yeah. So I'll just call this problem solving session in conditional probability. That's all. Maybe Bayes theorem is a part of it. Conditional probability, because this concept of conditional probability is really an original one, kind of. It's a slightly new concept, which all of you know, but you would see that that's where probability theory really, becomes more than what it is before conditional probability. Things really take a turn in the theory when conditional probability is introduced. So the basically I'll be focusing on the conceptual parts, because at least I have not very good concepts in this. Like I get confused sometimes. Conditional probability, or is it like A and B or A given B? That's a confusion that happens, right? And also the statement of the problem, and so that those are the things that I'll be focusing more on. But let's see what we can do. Yeah, so let's begin then. Let's begin with problems. So yeah, here is problem number 1. Okay, so 3 people. Okay, 3 people. Wait 1 second. Yeah, it's fine. 3 people. Let's say I, X, and Y. Okay, so there is me and there is X and Y. Okay, 3 people. Okay, 3 people are jailed. Okay, one will be released. Okay. Other two not. Other two, yeah, will not be released. Okay, and all equally likely. Yeah. So what I mean is probability is 1/3 of each person to be released is 1/3, because only one person will get released. Okay. So this is the setting. Yeah. Now let's say that I ask the jailer. Okay, I ask the jailer who gets released. Okay. Okay. So I asked jailer who gets released. Okay. The jailer knows it. Okay. But what the jailer does is he points to the other 2 people. Okay, and he points to one of them and says that one of them. So he points to one of them and says that that person will not be released. Okay. So jailer points to one of the other 2 and says, okay, he will not be released. Okay. So he points to some person and says that that person will not be released. Okay. So now, knowing this, what is the probability that I will be released? Okay. Knowing this, what we want to find is probability of I am released. Yes. Yeah. So the jailer points to one of the other 2. Okay. To X or Y, he points to one of them, and that who he points to, and jailer says that that person will not be released. So if you know this, then what is the probability that you will be released or I will be released? It's all in the phrasing. Okay. Yeah, so it is somewhat like that. Does anything actually change? What do you guys think? I mean, think about this. Suppose the probability of all three of you is 1/3, right? The jailer could have always, so I mean, out of those two people, the jailer could have always pointed to one of them and said that that person will not be released. Is that right? Yeah. So that is what I'm just thinking, that thinking from that point, it seems like the probability does not change. Yeah. Yeah, so that's where I am also thinking that this question is a little unclear. So when you are writing the answer, you have to be clear. Okay. Uh, so would anyone want to say both the cases in the Simon, compare both the cases, compare both the interpretations, maybe? Yeah, what do the other guys think? Chandan, Rasu bro, this. Yeah. So I will say that there are really two interpretations, and it's a little confusing to me also. To me, it's a little confusing, but if we fix the person, so if you are given that a certain person is not released, and if that person is fixed, if that's what they mean, okay, you understand, right? Like if so, this is not so this sentence, this is not saying that the jailer says that Y will not be released. It is not saying that. Yeah, that is still, there is a choice in that, and if that choice is really there, which is what the question is actually, on some sense, that is the only interpretation. Yeah, that really the jailer is, I mean the jailer will tell me one person, but really is not telling, I mean it's not told here, right? So in that sense the probability does not change, because I mean the jailer can always tell you one name, right, out of the two, in that sense. But if the question tells you that jailer tells me that Y is not released, uh, no. Okay. No, that's a little confusing. So if you're saying that probability, so you are saying that you are taking released. No, but you're doing, so what you're doing is you're splitting the base of the conditional probability, right? That you're not allowed to do, right? So X released or Y released, and then you're kind of splitting that, if I understand. Yeah, which is not the right thing to do. Yeah, so I'm saying that without going into the calculations, there are two interpretations. Yeah, and one interpretation tells you that, you know, the probability is 1/3. Yeah, because really you don't, because it is not given. Yeah, it is not given that Y is released or X is released. Yeah, the jailer can always tell you something. Yeah, so in that case, the probability doesn't change. But if you interpret it like, so if you interpret this knowing this, that you really know one concrete information, then the probability is half, obviously, because then there are two people, me and the person whose name was not told. And then, yeah, then there are two people and one of them will be released. So that's half. Okay. So there are these two, but I mean, it's mostly seems to be correct to go with this because it is not given to you that that the jailer tells you one thing. Yes, so to you the second one seems correct. Uh, uh, yeah, from that, but so can you tell the computational thing that you said, from the calculation? Mm-hmm. X is chosen. No, that is not doesn't have half probability. That's the thing. Because the jailer, that's the point here. The jailer is not randomly picking you. That's where the conceptual thing is. The jailer is not randomly picking one of the other two. You see, there is a difference. Yeah. The jailer can just pick one of them just to fool you. It is not given that the jailer randomly picks. You see, there's a subtle difference there. Yeah, if it was given that the jailer randomly picks, or jailer tosses a coin, but that's not happening, right? The jailer just points to you just to fool you, just to maybe give you a better feeling that you will be released. That's like we're thinking the probability becomes half, but it doesn't become half in that sense. Okay, because he's, yeah. Okay, so you did by formula. So can you then say, because I am not able to get it from a formula, I would love to get it from a formula. That is the problem. So just try to, let's see what, yeah. P of, sorry, P of AI, acha, this I you mean I. I is, okay. Okay, and by you mean given. Okay, so then go on. AI given. So you say given, don't say by. Given. AI given. Yes, total event is capital A. Uh-huh. No, so you're saying, so say this thing, so I'm just removing this thing, say this thing again. Okay. Oh, so this is the same thing as P of A. Yeah, that's always true, right? A slash slash. You mean given? Yeah, this is given. This is not a slash. Or Is it a slash? Ah. Right. No. So say the right part of the equality again. Uh-huh. Okay. A slash AI. Like this. You mean A given AI? A given AI. Ah, okay. Mm-hmm. Summation. So what formula is this? Is this the base formula you're using? Ah, okay. Summation P of A given. Okay. No, it is not slash. It's A given. Okay. I mean, I don't mind it, but you should. Yeah. A given A J. Okay. Let me just write plus only because. Huh. Okay. So this is the base formula. Is this the correct formula? Because I don't know. I don't remember the formula. I never use the formula as that, like that. I basically just go with the conditional probability definition. No. So is this correct? Is this formula correct? Okay. Right. And then so then after that, what you're saying that they are all equal or get cancelled? What? Ah, okay. So okay, you are saying that these three are equal in the denominator. No. Sorry. Um, so okay, just say that so the denominator is not correct, or is it correct? Arey Baba, why is this call coming? Just 1 second. This is the problem with these people. They just leave their phone and it just keeps ringing all day here. I'm getting disturbed, like you're saying, and then suddenly some call is coming, and then again, yeah. Sorry. So is the denominator correct? After simplification, it is correct. But so can you just say it without simplification? Yeah, I know. So you can just say base formula, but I just want to see it once because for all of us to just. Huh. Okay. Okay. So let's actually do it. Let's derive base formula using this. Okay, because it will be good exercise because that's so. This thing, I know that this thing is equal to. So what is this? This is this intersection and this, right? All of us agree this is the definition. So take it as a definition. This is the definition that all of us know. It's also intuitively making sense. Like if the probabilities are all equal, then it makes sense that A is the universe and so on. So this is the first step, right? And then we kind of use this, the symmetry of this. So we do it in the other way. So then this becomes, so we can take this like this, right? And then we get P of this. Is this correct? And then we have this. Yeah, please correct me if I am going wrong. Okay. So then this is the thing. And then this A is the whole event, and you split it, something like that, right, into 3 parts, and then you do some cancellation. But let's do it, okay? Because there are enough pitfalls in this theory. So we should just, so AI plus, I mean, let's do it even more carefully. So AX and AY, this is always there. Yeah. And this is the so that's wrong, right? It should be union, obviously. Like, so this event can be split into three parts, three disjoint parts here. And yeah, because only one person is released. So these are disjoint. That's important. Okay. So then we get, let's write this step. Okay. This plus AX, this thing. And again, we can apply the conditional probability. Wait, so this is this going correct? So this will just be P of AI, right? Yeah, anyone? Yeah, this should just be, this will just be P of AI. Like that is what, that is just what it is. So, okay. So then this is P of AI, this is P of AX, and this is P of AY. Okay. I don't understand. So no, but A is the whole event. So why will a slash come? So you mean this one, right? Yeah. So this one should be, so isn't this just P of AJ? No, because A is the whole event, right? And AI is contained in that. Or what is the whole event? That someone is released. Okay. But if you're not willing to, yeah, I can understand, because this is not the standard. It is usually not like that, because A is not the whole event. A is just something. So yeah. So usually, how do you suggest I write? You're saying uh, AI given A times P of A, like this, or should I write it the other way? I should write it the other way, right? Because that's why I'm using this formula. Yeah. Okay. So this should be P of AI. Okay. So you're saying that when you write it and expand it and then simplify, then you get what you were saying. Is that right? Okay. Right. So then that's fine. Yeah, that's okay. Yeah. So then from there, we were, yeah, then it's certainly 1/3, right? From there, it certainly comes out to be 1/3, because things in the numerator and denominator are same. Yeah, like there are three. Yeah. Okay. Cool. Good. Yeah. So we have kind of basically the keys to just see what you need, and then just write it. You get it. There's no need to remember a formula. Okay. But either ways, yeah. It's all, but always remember, it's always good, especially if it's a subjective question. Always, it's good to do it from the derivation. Okay. Otherwise, there can be a pitfall. Okay. I have this. I've seen this earlier. Okay. Right. So then let's move on. So this was a slightly conceptually tricky conceptual question, but anyways. Okay. Now you do something different. Okay. So now what you do is, you don't ask the jailer. Okay. But the following is true. Okay. The jailer has two chits of paper in his pocket, and they contain the name of the people who are not going to be released. Okay, so jailer has two chits of paper which has the names of those who are not going to be released. Okay, with the names. So you understand what this means. Okay, now you sneak into his pocket and you pick one chit at random. This is random. Okay, I pick one of them at random and find that my name is not there. So you can understand what the question is again. What's the probability that I will be released? And henceforth, let's not use any. So whenever if anyone is using a formula, just go do it from the definitions and say, because that is very important. Okay. Also because I don't remember the formula, so I get confused, but yeah, no worries. I mean, yeah, the formula is simple. Yeah. Okay. Is the question clear? Yeah. So the jailer has two sheets of paper in his pocket. I pick one of them. Now that's obviously random. Okay, because I am just sneaking in and picking one of them at random. And my name is not there. Okay? And obviously that doesn't mean that I'm going to be released. Okay. But given that, what is the probability that I'll be released? Given. So why is it half? Okay, tree diagram. Okay. Okay, so you're saying I have to. Okay. I get either X or Y. Okay, so you're using that. It's given that my name is not there in the chit. Okay. All right. So this is probability half. No. So if I get X, then Y is the probability half. It's I can see, but can you say it again? So you're saying this branch, why is it half? Yeah, so the jailer has two chits of paper in his pocket, right? And it has the names. And the names means the names of people who will not be released. And so the probability is half. Okay, so that makes sense. Yeah. And similar. Yes, because that was your reasoning was perfect last time, but only that time it was not random, because this is a very subtle thing. Yeah, this comes in different forms. The jailer, if he tells you the name, then that's not random, because he can always choose to misguide you, and that's all you need to answer that there is 1/3. Okay, but yeah, and so this is half. This is so. Does everybody see this? Yeah, Adish, do you see this? Sorry. Sorry. Okay. So then it's good, right? Because we're going slowly. So then tell us if there is something here which is not clear, because this is the time. I mean, that's why. This is okay. Yeah, I can understand. You're not answering because you're just following, but you should be able to follow because you can use it in other, yeah. So this is good. Let me see if there is if there's any logical problem. There is not, and the answer is also correct. Let me just check the answer. Yeah, the answer is correct. I will be released and I pick X. This is fine. Right, this is fine. So just to say it a little more, I mean, just differently, I will be released and intersection, I find X's name in the pocket or I find Y's name in the pocket. Yeah, this is really what given I don't find my name in the pocket means that I either find X's name or Y's name. It's a very good way to do this problem. Okay, by this interpretation, right? That given that I don't find, yeah. So because this is actually a question in conditional probability, right? If one just follows routinely, they can also do this. But this is a non-routine types. I mean, it's easy solution, very good solution, but it's a, yeah. So it will be given I don't find my name. And then you go by the usual conditional probability thing. Yeah, and then from there you can do. That I'm not doing. Okay, this is fine. Okay. So we see that there is a difference. Earlier, the answer was 1/3, and now the answer is half. Okay, this is what I learned from it. That if someone tells you something, you have to really see if it's at random or not. What is the situation? What is the context? Because in the exam, otherwise, if you're not used to these things, then you'll take it at random or you'll be confused, so on. And I find that my name is not in the, yeah. Then if in that case you really don't add anything. So if you're saying that if that condition of my name is not in the chit is removed, then then again the answer will be 1/3. Yeah, I mean, because you see, in any case you're going to get a if you pick a chit, you will get yeah. I mean, how does that add anything? Yeah, it's logically okay. Yeah, okay. Yeah, just knowing one name of someone who will not be released at random doesn't tell you anything. You have to be given something. Okay. Or if someone has the power to make it non-random and tell you some other name, then also he can always tell you some other name. That won't change anything. Okay. Subtle, I find this little because we don't do these things from the very foundations, just like we do number theory and so on. We do it from the very axioms, so there is never any confusion. But these things we are always a little okay. But otherwise, yeah, there's no fun. Okay. Let's do a similar question actually, right? Okay. So yeah. Yeah, in an exam you don't. If you're doing it from a book, then you can verify. But exam, yeah, yeah. In a subjective, you can write all the interpretations and do. There is no issue. Yeah, you can write your interpretations. You can write. That's why in these kind of problems, especially as suggested earlier, also that in the exams, write as much. I mean, write if something comes to your mind and you feel this is a case, write it. Okay. If you think whether I should write or not, write it. Huh? But if you write what interpretation you have made, then I think you should get something, right? But if you don't write anything, or if you don't write your interpretation, but just, yeah, you have to explain your interpretation. And if you try to actually explain your interpretation, then you'll actually, the other interpretation will also automatically come to you. If you just write what interpretation you have, that's the magic of writing, which is really very underrated. When you write it or when you type it, right, in detail, the other interpretation naturally comes because you become neutral when you write. This actually works because I've seen this many times. Okay, a lot of questions when you write, the other interpretations come naturally. Because I was thinking about this question, and this randomness thing was not there because I just saw the question is coming along the way. I was thinking, okay, this should be, that's all. But when I'm explaining you guys, then I'm getting the interpret because now I'm, you know, thinking on my toe and just doing. So that is the right. If you're confused whether I should write this or not, write it. I'm not saying just write, waste your time, but write. More writing is good. Okay. So let's do this next question. This is similar. Okay. So this is like magic show. Some not magic show, is like a lucky draw show. Okay. So there are 10 curtains. Okay. So there was a some das kadam or some kishmas, something like that. Kismat. So there are 10 curtains. Okay. One of them has a car, and the other 9 have goats. Okay. One of them has a car, other 9 have goats. Okay. So yeah, and then we pick one of them, and after we do that, the host, yeah, he pulls out 8 of the curtains which have goats. Okay, so I pick one curtain at random, and after this, that's important. Okay, after certainly important. Yeah, after this, the host reveals, I'll just say reveals 8 goats. Okay, so what is the probability that I have picked the car? So they are in the book they say winning, which is, yeah, but maybe that's what winning is. So yeah, what is the probability that, I'll just say, what is the probability that I have picked a car? Or the car? Huh? No, I don't pick a car. I pick one curtain at random. Why he reveals, I don't know. So I don't do anything. I don't know. I don't know if I picked a car. That's why we're doing probability. Yes. Right. No, that's right. So the answer is whatever you guys think, that the probability doesn't change. Yeah, it is 1/10. Wait, no, but someone said something different also. Did anyone say, does anybody think it? You said 1/2. Hello. Someone, yeah, someone explain. Yes, yes. Why do you think it's 1/10 and not 1/2? Yeah, but does the probability not increase, or does it remain the same? Yes. So far, yeah, and he can. Wait. Yeah. Yeah. So yeah, Adish, complete. You were saying something? Yeah. No. No. Okay. Yes, but you must understand that those 8 codes are not revealed at random, right? They are not revealed at random. I mean, this is something that he can always do, right? I mean, he's not because see, it was always known to you that there are 9 goats. Yeah. So he can always reveal 8 goats. See, think about this. Right? It doesn't really change the probability. Yeah. So I'm not explaining this in the best way. I'm not able to explain this in the best way. But Chandan, do you have an explanation? Yes, yeah, because your probability will not change. Just, I mean, just Rasova has thought of it in a very simple way that, I mean, what he does after doesn't really change the probability, right? I mean, you have already, so I mean, you think about it like that, it's just straightforward, right? You have already picked up, you got your thing, you went home, and then she showed you 8 codes. Well, how does it change anything? They can always do that. Yeah, that's what you said. Yeah, but it's very strange. I find this. It's not strange, but huh? I don't know the movie 21, so I don't know. Maybe it is there. Okay. Huh. And then he gets a chance to switch or huh. Okay, okay. Yeah, so we'll come to that maybe. Yeah. But let me just think of this once again. Okay, just to be yeah, I can understand that the answer is 1 by 10 and the reasoning is correct. Yeah, but you see, the point is that what I was saying that the host is not picking those the 8 goats at random. That's not a that's not a good estimation. Yeah, if you write that, it doesn't. Yeah, maybe it's better to say like what how Rasuvra said, or maybe you can also say that. I mean, he can always reveal 8 codes. He can always choose to reveal 8 codes. Yeah, and you still pick randomly. I think yeah, it's okay. Maybe it's so simple that is better. Yeah, that's what I'm thinking. Yeah, yeah, that's better. That he can always choose to. No, no. I mean, yeah, that you first yeah make it. Yeah. So Chandan, are you okay with this? Yeah, is it fine? Because huh? Mm-hmm. Hmm. Yeah, and even if I pick a car, you can still reveal 8 codes. That also. Yeah. Okay, Chandan. So what were you saying? Huh? Huh. Yes. But then how do you explain that these 8 goats don't affect? You have to give that explanation. Yeah. We have already explained it, but that explanation I don't find in your answer in so far. Hmm? Uh, okay. So was that your initial reasoning initially? I'm not, because I'm not very okay with that. But yeah, but I'm not very, because you're not saying how. But anyways, we have explained it. Fine. Yeah, that's okay. Cool. Cool. Okay. So fine. So that's okay. So let's then let's take the game forward, and that is um, uh, if the contestant switches. Yeah. What is the probability? So now it goes to reveal the contest. Yeah. Okay. That's a good way to see. The contestant switches. Okay. He does switch. Okay. Now what is the probability of getting a car? Nine by 10. Yeah. I mean, yeah, that seems correct to me. Adish, you had an explanation. Yeah. That affects because uh, because now more is known to you, right? And after that, you are making the switch. So one way to see it is what Raghav has said, that probability of getting a car after switching is, I mean, so when can you get a car after switching? You can get a car after switching if and only if you had picked a goat before switching, which probability was 1 by 9. Sorry, 1 by 10. Sorry, yeah, 9 by 10. So yeah, sorry, picking a goat earlier, right? So getting a car after switching is the exact same thing. And that's a foolproof explanation, right? And I think that's what Raghav said, that getting a car after switching is the same thing. And so the probability will also be same as getting a goat before switching. See, this is foolproof, right? This is because this is the exact thing. Yes, yeah, getting a goat before switching in the and that we know is 9 by 10. That was 9 by 10. Yeah, that is okay. That we know that initially the answer was 9 by 10. That we just discussed that for the car it was 1 by 10. So goat will be 9 by 10. Similar explanation. And this, so switching can change the thing. Okay. I mean, you can understand, right? Because then you are picking, I mean, then you know the bad things, right? So you're not picking from there. You're only in this world. And so that's making sense. Should change things. Yeah. That does not affect here, meaning we have we so in what way should I? Yeah, right. That's a perfect explanation. Because the 8 codes are revealed, That's why the switching is making sense. Right. Otherwise, what does it make? What does it mean to say switch? No. But no, yes. But see, what I'm saying is that switching can only make sense if you have two things, right? And the fact that you have two, because switching means that I am not, so those curtains which are revealed, those obviously I'm not going to use now, right? Those curtains which are unrevealed so far, those only, among those only I can switch, right? So you understand, right? So yeah, like see the contestant, so the host reveals 8 goats, but let's assume that he doesn't reveal your curtain, that the curtain that I picked. So this is the curtain that I initially picked, and this was the other curtain, and okay, and this is the another curtain, and the other 8 curtains are revealed, whatever. Okay, other 8 curtains are revealed. Okay, so now switching is between these two. So obviously we are using the fact that 8 goats are that those 8 goats are revealed, so those curtains are out of the question, and so we have 2 curtains. And after switching, if in this one, if I have to get a car, it means that initially I had picked a goat, and initially picking a goat was 9/10 because that happened before the switching happened. Oh, sorry, before the reveal of the other goats happened. So that probability was 9/10. Right. Sorry, what will happen always? No, but you are switching. So why will you always get a car? If you initially had picked a car, then you don't get a car, right? After switching. I mean, the contestant doesn't get both the things, right? Yeah. Okay. Yeah. If you get both the things, then it's certain that yeah, he gets the car. Then the probability is 1. Yeah. Okay. So this is the question. I think it's good to do this, right? Yes, I mean that's why we need maths, right? To answer the cases where the intuition tells you something else. That's the thing about intuition. Intuition is good, but it can also be misleading. Yes, that's right. That is right. Okay, that's why we are doing these things. Otherwise, we don't need formulas. One can just do everything with intuition. That's why we are doing these things. Obviously, it shouldn't go so much against the intuition that then we start thinking about changing the theory. Yeah, eventually we want things to match our intuition only, but obviously it won't. And if you think closely, it doesn't. Yeah, I think closely, but it will be surprising. But then when you see this explanation, then this also is correct logically and also intuitively, so then it is fine. That's the thing about intuition. Good explanation. So I've learned some good explanations today. So as I said, today I have to stop on time, but let me see. So yeah, so let me just give you one question and then yeah, you can try this. So instead of I just want you guys to try this first and later on we can say more on this question. So let's make it, so I'm paying 4 curtains because there are several steps in this problem now. There are 4 curtains and one of them has car and other 3 have goats. I pick, so once again, I pick one at random and the host reveals, but this time the host reveals not all, or rather, the host reveals 1 goat. So the host does not reveal 2 goats. Okay. If he reveals 3 goats, then everything is over. Yeah. And then you would know you have picked a goat or a car, whatever. Right. So he reveals 1 goat, not 2 goats. Okay. He reveals one goat. Now, after this, I am given a choice whether I want to switch or I don't switch. Okay. Now, whatever I do, the host reveals another goat. Okay. Second goat. Okay. Still, there is some uncertainty, right? So again, I'm given a chance whether I want to switch or I don't want to switch. Okay. So I'm having an opportunity of switching 2 times. Okay. And so I can switch 2 times, I can switch once, I can switch in the first time, not in the second time, or second time, not in the first, or I can switch both times, or I can switch none, no time. Okay. And all these 4 different things would lead to different probabilities of me ending up finally with the car. Okay. So what sequence of switches would maximize my probability? Okay. So it is simple in the sense, let me write the question and let's actually do one sequence. Okay. Otherwise, it's maybe gets hard. Maybe I don't know. Let's see. Let's try it. Okay. So let me first write the question because after this reveals. No. Host reveals one goat. No. There also it depends. The question could be very varied. In 10, if there are 10 curtains, again it could be like the host reveals one goat. He asks you, do you want to switch? uh, you decide. Then he reveals another goat. Again, he asks, do you want to switch? You decide. He does this 8 times. And then there are 2 to the power 8 ways for you to switch, right? The opportunity to switch. Oh, yeah. I mean, so is switching the right word here or? Yeah, but wait a minute. So, yeah, sorry. Yeah. So I think that's what you were saying. So there are 4 curtains and one goat is revealed. No, so switching here would mean that just changing your, if one goat is revealed, then there are 3 curtains and I have picked, let's say I picked this. So then what should switching mean here? Just any of the other 2, right? Yeah, it's fine. Then switching just means this, right? So this could happen for 10 goats, for the case of 10 curtains, one goat at a time. So there will be like 2 to the power 8, uh, choices which ones where you switch and you don't switch, and which out of those 2 to the power 8 uh, things would give you the highest probability of ending up with a car. That would be the question. But we're not going into that. That can be done once you see the pattern, what sequence of switches work. You can extend that pattern. No, that's the point. That's why I said there are, so you may switch. That's why. So let me write the question. um, yeah, so it's up to you where you want to switch, and you may not switch at all. Okay. That's why there is so many cases in this, and there are cases in this question. So after this the host reveals one code. Okay. I have opportunity to switch. Well, switching here just means picking out of the 2 unpicked unrevealed curtains. Okay. Opportunity to switch, because really there are 2 more curtains unrevealed, unpicked and unrevealed. An opportunity to switch, to change my decision. After this, host reveals one goat, another goat. Okay, obviously the one that is revealed, another one. Again, I have opportunity to switch doesn't mean I will switch. Okay, another, and this time I have to actually switch, because now I have just one more curtain which is unrevealed and unpicked. Okay. Yeah. So now the question is, what sequence of switches, I mean, if someone can answer this without calculations, then that's very good. Let's see. What sequence of switches will maximize probability of picking a car. Yeah, that's that seems. But let's do the case in which there is no switches at all. Okay, and let's calculate the probability. Okay, so that we at least know how to do this. You know how to do the work. Okay. Right. Yeah. So if there are no switches, oh yeah, that's right. That was easy. Yeah. No. So if there are no switches at all, then the wait. Oh, no, 1 minute, 1 minute. So initially the probability was 1/4, and I don't switch, and it reveals one goat. Then it reveals another, so obviously probability doesn't change. So this should be clear, but still, is it okay with everyone that if there are no switches, then the probability is 1/4? So let's actually calculate one more. Okay. Is this okay? Yeah. Okay. So switching first time, but not second time. Let's calculate this. What is the, so if this happens, okay, okay, then what is the probability of picking the car? Mm, 3/4 into 1/3. Why? No, I didn't understand. So three of these have goats. So if I have to, so I only switch once, and if I'm only switching once and getting, so that's 3/4. That's it. Uh, no, but I'm not switching. No. Huh. Okay. 3/4 into half. Okay, so let's do this. Is probably is correct. Uh, right. So let's do it like this step by step. So if so in the first attempt, so if I have to switch first time and I have to get a car, it means that initially I pick a goat, right? So this means that so this would mean that probability of goat initially, yeah. So initially I pick a goat, and that probability is 3/4. And that is clear. There is no doubt about that. I do that. Then the host reveals a goat. So let's say this is what I picked. Okay. The host reveals a goat. Now I'm switching. Okay. So now I have three. There are only two options now. Yeah. 1 minute. Yeah. So then in this two, I must, yeah, because I've already taken into account that I have picked a goat initially. Yeah, so that probability was not given. That's why I have to multiply that, and that's why I've already done 3 by 4, already taken it. It was not given, so I already took it. If it was given that yeah, then it would not be, but then it is into 1/2. Yeah, so into so if I want to get a car, then I pick a car from the two. Pick a car from two curtains, and we know one of them has a car. Yeah. Yeah, yeah, that is half. This seems correct. But if you want to just do this by conditional, so that there's nothing goes wrong, this thing is the same as picking switching. Yeah. So this means that picking a car. How do you write it in terms of can you write this in terms of I'll just check the answer also, but can you write this in terms of conditional probability? This is correct. Like, there's no problem with this because none of this is given. So we have to really consider them happening to happen. And so we have to consider the probability. So the probabilities multiply. But yes. I mean, yeah, that is fine. But can we write this in terms of conditional probability? We don't need to. Yeah. I mean, one can write it probably that given that first time switching and not given that I switched the first time and not the second time, but that's the same thing. And then, okay, let's actually do that, right? So picking a car given that, yeah, first switch and no second switch. Yeah, let's see if we get, I mean, we should get the same answer, right? But in this case, we don't need to do this, but in the cases where you probably make switches both the times and so on, you will have to. So this would be what? Picking a car and switching first time and not switching the second time. But that just gets more complicated, right? Yeah. 1 minute. Yeah. But then first switching the first time and not switching the second time, what kind of event is that? Probability that you switch the first time and don't switch the second time. Yeah. Uh, yeah, it doesn't seem to give. Uh-huh. Okay. Yeah. Yeah, okay. Adish, what you're saying? Yes, so that's what I'm trying, but I don't know how to apply condition probability in this. No, that's right. Sorry, you mean you've forgotten? No, but I don't see that. Yeah, but that's what I was also trying, but I don't see that condition probability being useful in this case. That's the problem. I mean, there is no such thing that it should, right? That in this particular case, sorry. No, there are conditions, but then there are conditions in every problem, right? But that condition is better dealt with when we do it in terms of intersections rather than, yeah. I mean, right. I mean, that it doesn't give you a Yeah, doesn't give you a benefit. Okay, we will see in some problems it does give you a benefit, and there we have to consider, but in this case it doesn't. Okay. So, sorry, can you say again? His voice is breaking a little bit. We have got two things. Yeah. Yeah, so there are two. Yeah, so that's okay, but that's not a problem, right? Because there are two boxes, but the reasoning is similar because there are two boxes, and we know that one of them has a car and one of them has a goat. Hmm. Must, much easier. But that way you will not get the probability of, you will get the probability of not picking a car. You will get some part, but you will not get the full. You will get some part of that probability, right? Because you see, yeah, not picking a car in the first attempt certainly guarantees that you won't get a, picking a car in the first attempt guarantees that you won't get a car after that in this case. But you may still end up with a goat even if you pick a goat initially. So that doesn't help with the problem. You see, conditional probability, unless it is asked, you have to really introduce it when you need to. Like, for example, I'll tell you, in the same problem, if you are given switching twice, then you can do conditional probability, right? Because then you get a car in the end. You can get a car in the end if you have picked a car initially also, if you're switching twice. Then you can do that conditional probability. You can try to apply conditional probability, right? So you can try that case of two switches and you can try to bring in conditional probability there. Okay. No, but it it will clarify things. So just try it. As I said, this is a remaining problem. Try it, and then maybe tomorrow I can do more problems of this kind, and obviously different kinds, different kinds. Yeah, uh, that will be good. Okay. Yeah, yeah. So this problem, it was there. One of my students had given me. So I don't know. Yeah, but he just so it was there with me and sorry. Oh no, but it is probably some American entrance exam also has these questions. Okay, so you can check that out. Yeah. So I don't know. Maybe so I have the snip, but most probably so they use this book called Intermediate Counting, right? Does anybody know? There's AOPS books are there, right? Hello? Yeah.